Let's do a quick introduction to version control and Git in particular. So, what's version control as a concept? Well, as a developer, you've probably noticed at various times of your development cycle, you make poor decisions and you'd like to be able to revert to old versions of your files, or you'd just like to have a nice history of changes to your project so that you can sort of, when you find some problem in a current version, trace your way back through changes that you've made in recent history to find the source of some problem. And version control is sort of a category of tool that is intended to help you basically keep a history of all of the changes that you've made to a given code base. And it's also really useful for helping people collaborate on different code on a shared code base. So if you have no version control and a bunch of people try to collaborate in the same code base, it's very hard to keep track of who made what changes. And it's nice to have an actual software mechanism to make sure that you aren't stepping on each other's toes, editing the same files, the same parts of the same files, overwriting each other's changes, and so on. So that's kind of what version control is. How about Git? So I'll start off with the concept of a repository. So what's a Git repository? It's a collection of code. You could think of it as just a directory. This is sort of the place where a project lives, a particular project. You can. This is not the only way to do this, but typically you'll have one repository per project, and that repository tracks all of the changes to that project, all of the history of that project. And there are sort of implicit repositories and implicit version control schemes. For example, Apple has, I think maybe it's called Time Capsule or something like that. I'm not a Mac user, so I'm not exactly sure what it's called, but they have kind of like an automated versioning scheme where you can go back and see the changes to all of your files in your hard drive over time. And there are sort of similar features in the Microsoft Office products, things called track changes, where essentially you're sort of encoding all of the changes that you make and sort of logging all of the changes that you make to a file, and that way you can go back and see who changed the shared Word document that's being emailed back and forth in a company and being changed by multiple people, in which ways at which times. And these are sort of implicit version control because all of the changes are being tracked, but there's no specific checkpointing mechanism to say this is a version that I want to kind of save and remember. And you're not giving names to your versions. The versions are just kind of being implicitly decided, kind of like an autosave feature. It's being decided by time or something else, not a user saying, this is a new version, here's a message to say, something about this version. There's, there's no name for a particular version. In Git, you have sort of explicit versions. And so you make a bunch of changes, and those changes are not stored really persistently in the repository. They're just made to your local copy until you commit those changes to the repository. And so you can commit a bunch of changes at once and write a little commit message. So I'll add that to the little note here. And these commits, they can either be sort of like a single sequence of commits that happen one after another, just the history of the repository, a linear history, or it could be a tree. It can be kind of branching. So you can take a given commit, a given version of the repository, and sort of fork it off, branch it off, and make some different changes while someone else is working along sort of a different branch of the repository. So you can have, different developers making different changes starting from the same shared commit, sort of branching in different directions, and then eventually you can kind of merge those, those changes back in. So that's kind of what branches are for, and that's why the commits form a tree and not just a single linear history. Before I get into the concept of remote and local, I'll sort of show you what that looks like. So here's a client, a Git client, a GUI client that I like quite a bit called gitkraken. I like it mainly because you can use this on Windows and Linux and Mac. It's super cross-platform, so it's nice to have the same experience in different places. So gitkraken is this tool. And here I have a bunch of repositories listed across the top. And here's one repository that I'm looking at, and I can see here all of the commits that I've done with little messages. So, for example, here's a commit where I added a README file, and down here, here's a commit where I updated some graphs and disabled, and I can click on these files. These are the files that differ in this commit from the previous commit. I can click on these files to see what's actually changing. Well, the binary files, it doesn't show differences, but for like a C++ H file, I can see exactly what was changed in the file. So I can do this for every commit, which is quite nice. You can kind of go back over time and just see exactly what's changing in the files and who's making the changes. This little icon is my icon, so I'm the one making all of these changes. So, and here, by the way, this is sort of the history. This is a very linear commit history because I'm working all on the master branch. Here I had an experimental branch which was kind of split off from the master branch, so the two branches diverged here at this commit. I branched, and then a bunch of commits happened on that branch. Some commits happened in parallel on the master branch. And another branch was spawned here and merged back to this branch, more commits on this branch, and finally this branch was merged, the experimental branch was merged. And so this is a whole bunch of experimental features, and this all got merged back into the master branch. So this is, I said it was a commit tree, but it's a commit tree if you discount merges. It kind of just is a graph because you can think of it as a directed acyclic graph, so where the edges are all pointing up. So you kind of branch off and you to make experimental changes or changes that aren't ready to be seen yet, and then you merge those back onto the main branch when they are kind of ready to be seen by regular users of the repository. Okay, so that's a quick overview of the commit tree and gitkraken. Very, very quick overview. How about this concept of remote versus local? So Git is sort of an interesting version control system because it was designed to be of use to programmers who have to work in large collaborative teams. And so you have kind of a remote repository, which is like the main repository. It's sort of the master repository. And then every developer who's working on a project also has a local repository. When you commit, you actually are making changes only to your local repository. And those changes are propagated to the remote repository where other developers can see them only if you push. So you have this concept of committing, which is in some sense a local change, but one where you're creating a commit message and sort of encoding some sort of, atom of, this is sort of what you've decided is the right granularity for a change. Like I like to keep my commits kind of thematic if I can. So, all the changes under a certain theme, I'm going to commit them together before I start some other change. And you might commit a bunch of things locally, and then when you're ready to sort of push this thing to the remote server, then you push. And the way that you pull stuff from the remote repository to your local repository is with the pull keyword. Okay. So for the purpose of this video, I'm going to talk about using GitLab. There are different services that provide Git repositories, the ability to host Git repositories for free. GitHub is like a super popular one. There's Bitbucket. I've been switching over to GitLab because I really like the way that they do their continuous integration, which I'll talk a little bit about. So here's GitLab as a site. You kind of go to gitlab.com and you can sign in. I'm already signed in here, so here are my projects. And here's a setbench project, which is one that I've worked on quite a bit in the space of sort of benchmarking concurrent data structures. So let's do a little tutorial on how you can use Git, the command line tool, to pull down, to clone this repository to get a local copy of this repository. So I'm going to click the clone button, grab the address here, and I can go git clone that address. And that's it. I'm cloning that Git repository onto some server where I'm going to compile it and execute it. And so, of course, to know how to compile and execute it, I have to go look at the installation instructions, usage instructions. So I have that open here. The usage instructions here tells you first you're going to clone it, then you're going to go to some particular folder, and then it tells you to go make -j all. So I'll do that, and boom, it's compiling. So I've downloaded all the code with that for the current head commit of this repository using the git clone command. I've compiled everything in it, and now I'm ready to run. And if I want to try running, I can just sort of copy and paste this dummy command, and boom, I'm up and running. So this was an empty folder prior to me doing the git clone, and here I've cloned, built, and executed the contents of a repository. So that was pretty easy on the command line. To do this in gitkraken, you go new tab, and then you go clone a repo, and you plug in the URL. That's not the URL. I forgot I already copied something else. Then go clone repository here. I can grab the, well, that's not a great URL. Let's go back to the set bench. That's the wiki. I don't want to clone the wiki. I want to clone the actual repository. So I copy that URL to the clipboard, paste it here, and you just specify where you want to clone to, and you click clone the repo. This is a local path on your system. You click clone the repo. It's going to ask you for a username and password for the repo, which is just whatever you configured as your GitLab username and password, and then it's going to commit it, clone it, and you'll have something like this. You'll actually have basically this view. Okay, so that's a quick crash course on git clone. That's sort of what you would need not to do development with Git, but just to do kind of like basic sysadmin tasks. Some packages that can't be installed from apt-get on Linux. You can clone their repositories, their Git repositories, and build them and install them that way. So, for that kind of use case, this is kind of all you need to know, how to clone and build and run things. But if you want to be a developer, then you actually need to know a little bit more about how to use Git. So I'm going to talk a little bit about some common usage patterns. So if you have a few different developers that you want to collaborate on the same branch, so if you guys are like working on the same shared feature, for example, then the typical workflow is you're gonna pull that branch initially, like clone the repository, work on that branch, make some changes, commit your changes, and now you would think, once I've committed my changes to my local repository, I should be ready to push my changes to the remote repository. But the problem is there's a concurrency issue here. While you've been making your changes, the other developers have potentially also been making changes. Maybe one of them has pushed to the remote repository. So now your local repository is actually out of date. And so the correct thing to do is you commit, and then before you push, you pull. This pull just helps you make sure that you're not going to miss any other changes. By the way, if you try to push right away, it'll fail if there's some other changes. But you might as well just try to pull. So you pull, and then if another developer made other changes in the meantime, since you pulled and made your commit, then you'll see that there are some conflicts potentially. Sometimes if someone else has changed, like a disjoint set of files, then the conflicts Git might be able to resolve your conflicts kind of automatically. And it'll sort of generate a new commit that's the result of your commit, plus all of the other changes that had happened since you pulled. So it merges your changes in, sometimes automatically, and sometimes if you and another developer modified a conflict, the same file, conflicted on the same file, then there's a manual merge conflict that you have to resolve. I won't go into too much detail on how to fix that, but in gitkraken, it'll sort of flash a red message on the screen and say there were merge conflicts, and then you'll see conflicts appear on the right side of the window, sort of in a box like this, and they'll have like some little icon to show that they're merge conflicts, and then you'll have to right click on them and go, resolve, and then it'll ask you, do you take your changes or their changes or some hybrid of the two? And that's how you resolve your conflicts. Once all the conflicts are resolved, then you push. And as long as no one else concurrently made even more changes that you have to merge with, your push should succeed. So collaboration on the same branch, the pattern is make your changes. So I'll write that here. Change things, then commit, then pull, then merge your changes with their changes, and then push. And this merge step will usually result in a new commit. Okay, so that's collaboration on the same branch. How about developing a new feature and nobody else is helping you develop that feature? It's just your job to take that feature and develop it. So the typical approach is you take the head commit on the master branch and you create a new branch that just sort of copies that master branch's commit. It branches off of that master branch's head commit. So you create a new branch. The way you would do this in gitkraken is you click branch, and you click create branch here, or you can click branch, type a new branch name, and it will branch this commit, creating a new branch. And then you make your changes. So I'll say that here, make changes, and then you commit and push to your branch. And you might do this many times because you're sort of working on your own private branch in some sense. And so you can commit and push to your own branch. If no one else is working on that branch, then you won't encounter any merge conflicts on your branch. So you're committing, making changes, committing, pushing, making changes, committing, pushing. Your changes are going up to the remote server, but they're on your own branch, which is on both your local server and the remote server. And so as you're committing and pushing, you're not conflicting with anyone else. You commit and push many times. Finally, when you decide, look, your feature is fully developed, it's ready to be merged into the master branch, then you merge your branch. The way you merge your branch is you sort of right click and you go merge. You don't, well, in this case, it's showing merge master into experimental, which is my branch. I don't want to merge the master into my branch. I want to merge the branch into my master. But if I right click on the right I've already merged this, so you can't really see what the right click context menu would look like, but you want to merge your experimental branch, your feature branch onto the master branch. And then if there are any conflicts, again, you have to resolve your conflicts. And then once you've resolved your conflicts, you commit that merged commit to the master branch, and you push your changes to the master branch. And then if someone else concurrently made even more changes, you may have to repeat resolving conflicts, committing and pushing. So developing a new feature, you branch, make as many changes as you like on your own branch, and then as soon as you're ready to merge that into the master, you merge the branch into the master, resolve any conflicts, and then commit that conflict resolved set of changes and push to the master branch. Okay, so those are sort of the common design patterns for using Git. In some repositories, I'll mention that when you're developing a new feature, in some repos, you may not have permission to actually merge. So you may have to do what's called a pull request. So in this case, you submit a pull request, and once you've submitted a pull request, an owner of the repository has to review your pull request and accept it or reject it. And they'll actually kind of execute the merge into the repository. So I won't show you directly how to do that, but just so you know that that exists, that's kind of another popular thing, popular design pattern. Okay, so that's it for this video. In the next video, I'll talk about continuous integration on GitLab and pipelines and the GitLab YAML file and so on. All right, thanks for watching.